Good day, everyone, and thank you for the opportunity to join you for the discussion of this very important topic of molecular diagnostics in the medical examiner setting, or molecular autopsy. I'm Jason Graham. I'm the Chief Medical Examiner of the New York City Office of Chief Medical Examiner, and I'm enormously pleased to share with you today an overview of the evolution of postmortem molecular diagnostics or molecular autopsy over the past 2 decades at the New York City Office of Chief Medical Examiner. Molecular diagnostics has really become crucial for determining the proximate cause of death and for informing proactive, life-saving clinical care for families in so many of our cases. Molecular autopsy is a powerful tool in our toolkit for those of us practicing forensic medicine, and it's one that is significantly underutilized in the U.S. Our office operates the only municipal molecular genetics laboratory in a medical examiner's office in the nation, and we fully acknowledge how very fortunate we are to have such resources here in New York City, especially at a time when so many medical examiners' offices are struggling, particularly in the midst of the opioid crisis. And so today I'll discuss implementation of molecular diagnostics in our office, along with some of the obstacles and possible solutions to achieving broader implementation of this type of testing across the country. And I'll also share some thoughts on how our office may possibly offer assistance in addressing some of these needs in the future. So I'm pleased to lead off with the first of 5 presentations about the value of molecular autopsies. From my perspective as a chief medical examiner first, and then from the perspectives of a forensic pathologist, a laboratory director, a clinician, and a genetic counselor. And I'm sure that these are going to be really interesting discussions that each of these professionals will offer on this topic. This appears in the front lobby of our 520 First Avenue headquarter office here in Manhattan in New York City, and it's a Latin phrase that translates, "Let conversation cease, let laughter flee. This is the place where death delights to help the living." And postmortem molecular diagnostics, or molecular autopsy, really epitomizes this statement, not only through providing answers to families during some of the most difficult moments in their lives, but particularly through the active life-saving potential that this work brings to forensic medicine. And I'd like to demonstrate this, hopefully, through discussion of a recent case that was investigated by our office. So the decedent in this case was a 33-year-old Hispanic man who sustained a fall at a subway station on the stairs. He became dizzy, fell. He refused medical attention despite having some injuries. He had abrasions to the right side of his head and one of his arms. Later that day, several hours later, after going home, he was found unresponsive on the floor of his bathroom at home. 911 was called. EMS responded but wasn't able to resuscitate him. The only medical history that he had really was a prior right shoulder dislocation. He had some vocal cord issues at one point and had a questionable history of remote substance use. But his autopsy revealed the cause of his death to be the rupture of an aneurysm of the innominate artery, or the right brachiocephalic artery. Initially at autopsy, it was questionable as to whether or not this was a tumor that might have been growing from the blood vessel, but that was eliminated with our microscopic examination. There was no tumor there. This was purely an aneurysm of the innominate artery, which ruptured and caused an enormous amount of internal blood loss and caused his death. We proceeded, given his age and this unusual anatomic finding, we proceeded with the molecular genetic testing to include our aortopathy panel, which tests for 20 genes in our molecular genetics lab here in-house. And we used the bloodstain card that was retained at autopsy for this testing. The results in his case revealed a pathogenic variant at the collagen 3A1 gene. And this is diagnostic. It's sufficient to make a molecular diagnosis of vascular Ehlers-Danlos syndrome. So this is the proximate cause of death in this case. It's vascular Ehlers-Danlos syndrome, or VEDS. And this is a look at the phenotype of some of these individuals. Very characteristic facial appearance, small features, thin lips, nose, mouth, narrow palate, uh, deep set or large almond-shaped eyes, attached earlobes. They also have other features, physical features, phenotypic features of VEDS, such as easy bruising, early varicose veins, very hypermobile joints, and the mutation is on the short arm of chromosome 2 there, the collagen 3A1 variant. They are at greatest risk based on these potentially serious complications involving rupture of arteries, rupture of the intestine, rupture of the uterus, potential development of pneumothorax. So there are life-threatening consequences of having this genetic variant and being a vascular Ehlers-Danlos syndrome patient. Importantly, on the right of the screen, the life expectancy for these individuals is only 51 years old, and 1 out of 50,000 people in the U.S. are impacted by this. 25% of those individuals experience a major complication by the age of 20, and 80% of them experience a major complication by the age of 40. So this is the individual's pedigree, and the decedent here is in blue. The several family members of his show the signs of VEDS. The decedent has one full sister who was the person who spoke to our genetic counselor, and the sister is a nurse who had urinary tract issues as well as easy bruising. She has 4 children ranging from the ages of 3 to 11. And the girls have flexibility, hypermobility of their joints, easy bruising. 2 girls tend to walk on their toes. The decedent has 2 half brothers by each parent, and the sister doesn't know whether they have features consistent with VEDS or not. The decedent has a son that is 11 years old with unspecified heart issues, and his parents are alive, but it's unknown whether they have the phenotypic features of vascular EDS, because there is some paternal history of having prominent eyes on his father's side of the family, but details are really limited because these family members are living in the Dominican Republic. And so VEDS is an autosomal dominant disease. All first-degree relatives have a 50% chance of having the same pathogenic variant, and those with the phenotypes particularly need clinical evaluation and targeted genetic testing and counseling. And so with the knowledge of our molecular diagnostic testing results from this case, and with the benefit of genetic counseling, the family members who are at great risk now have the opportunity, and again, 25% by age 20, and by 40, 80% of patients will have a major complication. And so these family members have now the opportunity to really take proactive action that could save their lives as a result of this critically important testing. So I'd like to move on to our office and the experience of implementation of molecular autopsy that has really evolved at the OCME here over the past 20 years. And I'll start first with just a brief overview of our office in general. The largest medical examiner's office in the country. We have over 750 employees, and we have We're home to the first toxicology and serology, forensic toxicology and serology laboratories in the nation. Our DNA crime lab is the largest municipal lab of its type in the world, and we have, as I mentioned, the only molecular genetics lab housed in a medical examiner's office in the country, and we're busy, as you would imagine. We handle roughly 30,000 calls a year and bring roughly 12,000 decedents into our custody each year. That consists of 6,000 or so autopsies, 3,000 views or external exams, and then cases that come in for in our role as the city's mortuary for claim only and release to funeral homes. And we also review all the cremation requests in New York City, which is about 20,000 or so a year. We have offices in all 5 boroughs of the city, but we only perform autopsies in 3 locations. That's our forensic pathology centers here at the headquarter office in Manhattan, as well as our forensic pathology centers in Queens and in Brooklyn. We have family service centers in Staten Island and the Bronx for families to come in. And so we have our DNA laboratory and our molecular genetics laboratory located just down the street from our headquarter forensic pathology center at 30th Street on 26th Street here in Manhattan. That's the Hirsch Center for Forensic Science, which I'll show you right away. This is the Hirsch Center for Forensic Science building, a beautiful 13-story building, glass facade. The molecular genetics laboratory is located on the 7th floor of this building and has 9 staff members and has been in existence for 20 years. Been accredited by the College of American Pathologists since 2011, so for the past 12 years has been CAP accredited. And our current sudden death panels include the 132 cardiac gene focused panel, a 159 epilepsy gene focused panel, 20 aortopathy genes we test for. We also test with panels for malignant hyperthermia, as well as thrombophilia gene mutations and sickle cell disease. So the molecular genetics laboratory in our office has made an enormous contribution to the practice of forensic medicine in New York City, and I want to share with you on the next slide some of the history, just an overview of essentially the past 20 years, and then begin looking at some of the directions we would like to take going forward. So the namesake of the building I just mentioned, Dr. Charles Hirsch, our longtime chief medical examiner, and really an icon in the field of forensic pathology, mentor to so many of us. Dr. Hirsch recognized the need to retain specimens, samples that DNA samples for potential genetic testing, and this is there's certainly a need for awareness of the need for DNA testing and the power of DNA testing. Dr. Hirsch in 1994 instituted an agency-wide policy of saving bloodstain cards for all cases for DNA testing, and so Dr. Hirsch was joined by Dr. Barbara Sampson, his successor. Dr. Sampson really, with Dr. Hirsch's support, internally drove the establishment of a molecular genetics laboratory. And Dr. Sampson convinced Dr. Hirsch to recruit Dr. Ying Tang, who is a board-certified clinical molecular geneticist who had just finished her fellowship training at Mount Sinai here in New York City. She was recruited by Dr. Hirsch and Dr. Sampson to join our forensic DNA lab to develop molecular autopsy, and that was in 2003. So that really marked the birth of molecular diagnostics at the New York City OCME. And so with existing lab space and equipment in our forensic DNA lab in the, at that time, brand new DNA building, which subsequently was named after Dr. Hirsch, Dr. Tang successfully attracted several PhD level research scientists to join her and to establish and validate several molecular diagnostic testing panels using the constantly evolving and improving sequencing technology They began testing postmortem bloodstain cards or also tissue samples that were preserved in RNA later preservative solution. And since they became CAP accredited in 2011, Dr. Tang's team has also been successfully awarded over $2 million in funds from the NIJ competitive research grants, which enabled cutting edge next generation sequencing testing panels to be developed and also to recruit the first genetic counselor, that clinical genetic counselor that we hired in 2016. And we are moving forward looking at new ways of serving our community, not only families that we deal with day to day, but also potentially the broader forensic community. And so I'll talk for a moment or two about a couple of those initiatives that we see in our sites for going forward. First is what we're referring to internally as GIFs, or Genetic Intervention Family Testing Services, which we are going to provide in-house genetic testing for affected surviving family members of decedents who have died suddenly or unexpectedly of a genetic cause. And so this is based on a need that we have identified in our experience dealing with these families. There are a number of barriers for families to get testing, even with the knowledge that they are potentially at risk, and even having been the recipient of genetic test results for a decedent family member. And so our intention is to reduce the barriers to getting that testing by offering clinical testing for the at-risk family members in-house. We've been asked to do this by family members who would otherwise not get this testing because of limited by the insurance costs, making appointments at the clinic, going to a clinic, overcoming the barriers, language barriers, cultural barriers, so many barriers that exist for families that are disadvantaged in many ways. And so our goal is to provide more equal access to testing, to streamline the coordination of testing with these families in order to not only get the testing done, but also get them plugged into clinical care that will have potentially life-saving benefits and really provide them with earlier medical intervention. We are hoping, and as you see in this pedigree to the right, the at-risk family members are numerous in many of these family and social networks surrounding the decedent. And so we're hoping within a year bring online our GIFts program and start clinical testing of surviving family members in our cases here in the city. We also, going forward, are interested in possibly expanding our services beyond New York City and serving as potentially a national reference laboratory. We have now 20 years experience performing postmortem genetic testing, as well as the interpretation of those test results, which is an enormous area of very niche expertise that Dr. Tang in particular has developed. And we're looking at the opportunity to potentially, through either federal grant funding or through a fee-for-service model, potentially offering molecular genetic testing services to other jurisdictions. And in those scenarios, there are several potential options. We would potentially perform the DNA extraction on postmortem samples, either bloodstain cards or tissues. And we would either perform the DNA testing in-house, that would be directed testing based on the autopsy findings and communicating with the referring jurisdiction, perform directed in-house molecular genetic testing and issue reports from our own lab, or potentially doing the DNA extraction and sending the DNA extracts out to a laboratory of that the local jurisdiction would have selected or contracted with for whole genome testing. And we would also potentially, when those results are available, help with the interpretation of those test reports. So there's several potential ways that we are looking at expanding our services to try and help other jurisdictions. Another way, separate and apart from the actual bench work and laboratory reporting function that we're looking at, is the opportunity to assist other jurisdictions and identifying for the families that they serve the local genetic counseling networks and or potentially genetic clinical networks that would be important to be able to connect families with. So this is also pending. We are working toward this, and so this is aspirational that we would be able to potentially offer some of these services, hopefully within the next year or so. So we, as I mentioned, over the past 20 years, our molecular genetics lab has not only been hard at work doing clinical, our postmortem clinical work, but they've also published roughly 30 peer-reviewed articles on molecular autopsy alongside others who have been producing studies worldwide, all supporting the values and the importance of molecular autopsy. And so I wanted to spend a moment or two to highlight the fact and show some examples of the practice guidelines for professionals with regard to molecular autopsies. And the first set of guidelines that I'll refer to is the 2020 international guideline developed and endorsed by the multiple organizations that you see here, the Asia Pacific Heart Rhythm Society and the Heart Rhythm Society on the headline, but this was an international effort that produced this consensus statement on investigation of decedents with sudden unexplained death and with patients with sudden cardiac arrest and of their families. And the guidelines, this may be a bit hard to read because there's a lot on this slide, but in the investigation of a death, this set of guidelines first recommends storage of the DNA sample, a blood sample, taken at autopsy or during life, if it's a living patient, obviously, for cases of suspected a death due to a suspected genetic cause. A referral to the multidisciplinary team for genetic investigation for the family is recommended. If after a full investigation, the postmortem examination, autopsy, the decedent is shown to have a known phenotype, if features are present and identifiable, things like cardiomyopathy, molecular testing panels for the genes associated with cardiomyopathy are recommended, as well as family testing and genetic counseling. So if the phenotype is known, targeted genetic testing, family testing, and counseling. If the phenotype is not known, and this is a sudden unexpected death, the suggestion is that the arrhythmia syndrome focused genetic testing panels are to be performed. And the absence of a phenotype and the absence of a working hypothesis, a hypothesis-free attempt at whole genome sequencing, they really do not recommend. They do not believe that there's benefit to that. So that would be a genetic fishing expedition that is not productive. So those are the recommendations that were offered by this international expert consensus group. The National Association of Medical Examiners in 2013 also offered a position paper dealing with retaining postmortem samples for genetic testing, and the name recommendations are around when to save a sample, and ideally that a sample should be saved in all ME cases. But at a minimum, the name recommended samples to be saved in individuals who are 40 years old or younger. And then also circumstances that should be considered to be suspicious for a possible genetic etiology would include, but not be limited to, the following that you see on the screen. Drownings, particularly in cases of non-intoxicated or very experienced swimmers, single motor vehicle accidents when there are apparently no mitigating factors like the non-intoxicated drivers, favorable road conditions, etc. Unexplained seizures in a young person, cardiomyopathy or aneurysm, which we've dealt with already, and unexplained death of an individual with family history of sudden death or inherited heart disease like cardiomyopathy, aneurysm, other genetic cardiac causes. And then all deaths that are sudden and unexplained where the cause of death is not clear at autopsy. And in terms of the samples to be saved and the conditions under which they are to be saved, the name recommends a liquid blood sample, 5 to 10 milliliters in a lavender top EDTA tube. Short-term storage for less than a month can be in refrigeration at 4C. That can be shipped overnight at room temperature to a clinical lab for testing. Longer-term storage over a month the samples need to be stored in a -20 or a -80 freezer, and then shipment of those will require shipping in dry ice. So those were the name guidelines from 2013 in their position paper. Also this year, the American College of Medical Genetics and Genomics also published guidelines and recommendations for laboratories, genetic counselors, and clinicians on facilitating postmortem genetic testing. So there's a set of practice guidelines and recommendations that are out there, providing some guidance on sampling and types of cases to hold samples for. We want to shift gears a bit and talk about some of the obstacles to broader implementation of molecular autopsy. And I think the single most obvious barrier or obstacle is cost, and cost in a variety of ways. Health insurance coverage is essentially non-existent for post-mortem testing for insured decedents who were insured during their life, and so that would be, simply for determination of the cause of death. Insurance companies will not pay for that, and so the insurance companies may possibly pay if testing is indicated for an insured living family member, customer of theirs. So, but in those instances, it is a complex process that has a bureaucratic sort of set of loops that have to be jumped through in terms of the clinician requesting the testing, the family obtaining the authorization. So it's a labyrinthine process attempting to get insurance companies to pay for the testing of postmortem samples for the sake of the living relatives of the decedent. Otherwise, and this is probably maybe the most significant given what I've just spoken about, the cost of this testing falls on the medical examiner's office. And we all know that medical examiner's offices are relatively underfunded, and it's nearly always the case when medical examiner's offices are competing at the local level for funding against the police department and the fire department and EMS. We know how the balance ultimately lands. So costs that are significant to medical examiners' offices, knowing that medical examiners' offices have very limited budgets. And then most medical examiners' offices beyond that have no capacity, infrastructure-wise or otherwise, capital budget-wise, to develop their own in-house testing. And so cost is a major barrier on a lot of levels to the broader implementation of postmortem molecular diagnostic testing in our country. Another barrier has to do with the samples and lacking, uniform protocols across the country for saving samples that are ideal and suitable for postmortem molecular diagnostic testing. There's difficulty with shipping. If you have to ship frozen tissues, the difficulty of dry ice shipping and making sure that the timing is appropriate so that the recipient processes the blood or tissue in an appropriate manner and maintains the freezing conditions, etc. That's a complexity. In addition to that, most commercial labs do not test a range of postmortem sample types, like bloodstain cards even. So that can also be a challenge. The commercial labs would test a DNA extract, but in other words, DNA being processed and extracted from a sample at an outside separate laboratory, and then that DNA extract being sent to the testing laboratory for testing. They would accept DNA samples, but the idea that there is access to a lab that would do just DNA extraction is really negligible. So these are some of the barriers to broader implementation of molecular genetic testing postmortem in the country. I think there are things to consider in trying to bring molecular autopsy into your morgue with the operating assumption that for most there's little to no capacity to develop in-house postmortem molecular genetic testing given the budgetary constraints and other things we just talked about. So with these constraints in mind, but with, I think, our mutual goal of fully integrating molecular diagnostics into the forensic investigative toolkit, a few points to consider would be around what samples to save given storage and shipping requirements, how to find a lab that will get you the test results you need, understanding the genetic testing reports that you'll receive from any of these labs, and then the communication piece with families, which is mainly focusing on genetic counseling. So we'll look at each of these one by one briefly. First, the samples to save. Liquid blood, as I mentioned before, is the recommended postmortem sample of choice. There are also options for tissues to be saved either in RNA later, which is a special solution for that stabilizes the RNA, DNA, and preserves it, and then also frozen tissues. The pros are that DNA is abundant and stable. Commercial labs do offer testing of each of these three types of samples to be saved. The limitations or cons have to do with the storage space and freezer requirements that are needed. Anything stored over a month needs to be in a -20 or a -80 degrees Celsius freezer. And then those samples have to be shipped, as I mentioned, on dry ice. And so this has storage and personnel implications for managing those samples. Another type of sample that we routinely save in addition to tissue for RNA later is the bloodstain card. And so preserving DNA on bloodstain cards has many advantages. Obviously, the dried blood spot on the card contains DNA that is stable. The bloodstain card is easy to make. Medical examiners can make and manage their own cards. They are easy to store. This is one of our typical bloodstain cards. See the blood supplied, it air dries in those circles. There's a cover that's part of the card that we use, and then they're sealed in these packets in an envelope that are for easy storage, high density shelving, lots of capacity for long-term storage in a relatively small space. No refrigeration is needed. It's also easy to ship the bloodstained cards by mail or courier, etc. The cons have to do with, or the downsides have to do with what commercial labs tend to require in terms of the blood cards themselves. They generally require use of their proprietary sample collection cards, and very few commercial labs offer testing on generic postmortem bloodstain cards. And so a possible solution would be, again, going back to what I mentioned about some of most labs taking DNA extracts and testing that. Essentially all the labs would take extracted DNA and test without those same concerns as using their commercial product, proprietary products, etc. So moving on to finding a lab for postmortem genetic testing. In addition to, the well-known labs at academic medical centers, let's say for Mayo Clinic, for example, among others, another way to find a postmortem genetic testing lab is to search in the genetic testing registry database, which is managed by the NIH. NIH through the National Library of Medicine, National Center for Biotechnology Information. And we have here on the screen an example case. If you are wishing to test for hypertrophic cardiomyopathy using a dried blood stain card, the registry shows 4 labs in the US. But it's important to, and this is just an example of a single search, it's important to contact the individual labs to confirm for that specific lab what their sample requirements are, as well as their fees, etc. They may be only accepting samples collected using their own cards, etc. So you really have to contact the lab that you identify through this source in order to make sure that their requirements are met and that you'll get the testing done that you need. The other thing to be aware of about this registry is the fact that the NIH doesn't independently verify information submitted to the genetic testing registry, and so the registry the registry is also participation is voluntary there. So just a couple things to be aware of. But this should be a helpful resource to you in trying to find labs that will perform the testing that you need. Now, after testing is done, you will receive your genetic testing reports, your diagnostic results, which generally provides a result falling into one of 3 categories for a given genetic test. The positive result is the presence of a pathogenic or likely pathogenic variant. So this is a positive finding. This is a positive test result. This is diagnostic and explains what you see at autopsy, explains the phenotype that is, and provides you with the proximate cause of death. In our case example, the rupture of the aneurysm of the innominate artery in this young man, the proximate cause of his death was the genetic variant in that collagen gene that caused him to be able to be diagnosed with vascular Ehlers-Danlos. So this is a positive finding and diagnostic of the cause of death. There could be situations in which a pathogenic variant may be present, but it may not necessarily be implicated as the cause of death, or it may not have anything at all to do with the cause of death, but it still could be certainly important to the family. But that's more rarely the situation. I think that the vast majority of cases, when you get a pathologic variant, it is diagnostic and does help explain the cause of death. And of course, in this instance, genetic counseling is recommended, and familial testing of the surviving family members may certainly be warranted. The second option, the second category of results that you would receive would be a variant of undetermined or uncertain significance, or a VUS. So this is not diagnostic. It may or may not have been the variant that is detected. It is unknown whether or not this contributes in some way, mechanistically, pathophysiologically, to this person's death. And so it is not diagnostic. It's simply present, and it cannot in and of itself implicate this genetic change as the cause of death. This is also a situation, because of the uncertainty involved, that genetic counseling is recommended, and that familial testing for the family may be warranted. This pedigree needs to be ascertained. Genetic counseling for the family is needed, and there may be other family members at risk that need to be tested. And then the final option, generally speaking, is a negative result, no reportable variant. There was no variant or genetic change, or the outdated word mutation. None of those are found in the genetic testing that was performed. And so no reportable variant, that's a negative result. So you can't exclude in these instances the possibility of a genetic etiology or a genetic change that that potentially caused the death, but the genes that you have tested for, the likelihood that they are involved as a cause of death are very, very much reduced. And so this situation, if there is continued concern, may lead to potentially expanding to other types of genetic tests, other panels, even potentially whole genome sequencing, depending on the specifics of an individual case. So this is just some basic ways of understanding genetic test results, which can be extremely complicated, and the interpretation of the variants that are detected by genetic testing is a very specific skill set that has to be applied by medical geneticists in the lab, and Dr. Tang, as I mentioned, has become really truly expert in this over her 20 years experience doing postmortem work. And we're certainly the beneficiary of that internally at our office. And then finally, a word on communicating with families. And the pedigree to the right shows multiple family members of this decedent who are, at great risk for having a genetic condition that potentially threatens their life. And genetic counseling is basically described as the process of helping people understand and adapt to the medical, psychological, and familial implications of the genetic contributions to disease. And genetic counseling should be conducted by board-certified genetic counselors. They collect pedigrees like this, they identify at-risk family members, and they are really uniquely trained, not only with genetics expertise, but they are having very compassionate discussions with the families, and they are helping the families with informed decision making so that they can make take the best care of themselves and their family members that they possibly can. So, and we're, again, very fortunate to have a certified genetics counselor on staff at our office as a critical member of our molecular genetics laboratory team. So there's a way or two, I think one of the ways that we at the OCME in New York City are looking at potentially assisting with some of these needs to help, ultimately obtain our goal of a broader implementation of testing across the country. We're looking at the possibility, I mentioned this before, of serving potentially as a reference lab in the future within the next year or so, either grant funded or establishing a fee-for-service service to, at the minimum, maybe do DNA extraction on blood-stained cards and either then proceed with testing ourselves and interpretation and issuing reports from our lab, or being able to send those DNA extracts to whatever labs are necessary in order to get the testing done for any jurisdiction that seeks that type of help. And then I mentioned also the idea of assisting other jurisdictions through our experience in our networks, local genetic networks in that jurisdiction for the benefit of the families to get them the clinical care that they need. So look for more to come on that. And I'll just conclude by summarizing that what we've talked about. First of all, I've shown an example, I think, of the value of molecular autopsy through a recent New York City case. I've tried to illustrate how our office implemented molecular autopsy and the evolution of what's taken place here over the past 20 years, as well as a look forward. We reviewed practice guidelines for molecular autopsies, talked about obstacles to implementing molecular autopsies in the U.S., and discussed what are some points to consider in trying to bring molecular autopsies to an office with perhaps limited resources. And I hope we all can agree with the idea that broader implementation of postmortem genetic testing in the United States is needed, and saving samples suitable for molecular genetic testing is certainly an important first step. To the extent that that's not occurring now in any jurisdiction, I think that that would certainly be a first step and move in the right direction. And then again, we now in New York City have over 2 decades of experience in this work. And as we look forward, we're looking at ways of expanding our genetic testing services to our local communities and the families that have lost loved ones here in New York City. But we're also working on ways of possibly assisting you, our colleagues in the broader forensic medicine community going forward as well. And so with that, I will close and say thank you very much for your interest and attention, and I look forward to the roundtable discussion.